Alright, ladies and gentlemen, boys and girls of Doom. We are going to start the next practical, which is the experiment E2. And we are going to look at the table first. I guess this experiment is just to test your understanding of resistors in series and resistors in parallel. Alright? This experiment is just to test your understanding on resistors in series and resistors in parallel. Let me adjust this shade here. All right. So you are given the resistance for each of the resistors here. The values we are given for the first one, R1 was 1 ohm. R2 was also 1 ohm, right? So the equivalent resistance for resistors in series, we usually say that R equivalent is what? R1 plus R2. So our equivalent resistance for this case will be 1 plus 1, which is equals to 2 ohm. All right, that's our equivalent resistance. So what we are going to do now is find V over I. V over I, recall from Ohm's law that V is what? IR. So for us to get R, divide both sides by I. Divide both sides by I. So when this cancel this, your R is V over I. So it is expected that whatever value you have at your V over I here is your value for your what? Resistors. Are you getting resistance for each of them? Are you getting it? So let us calculate. For the first one you have here, you have 0.7 divided by 0.3. What do you get as your answer there? 2.333 into 4 decimal place. All right, 2.333 like that. Okay, let me use the purple color pen. So we have 2.3333. Now the next one is 0.6 divided by 0.28. That will give us 2.1429. The other one is 0.4 divided by 0.26, which is 1.5383, I guess. 385. Then the other is 0.4 divided by 0.2, which is 2.0000. And then the last one is 1.2500. So these are your various equivalent resistances for each of the cases we have. Are you getting V over I, which is your resistance? Now, the question here says, obtain the average value of V over I. Now, how do you get the average? You add everything here together and divide by total number, which is 1, 2, 3, 4, 5. So this will give us 2.3333 plus 2.1429 plus 1.5385 plus 2.0000 plus 1.2500. Now everything here divide by 1, 2, 3, 4, 5 divided by 5. First, when you total everything there, what did you get? You got 9.2647. So you have 9.2647. Now when you divide this by 5, that will give us 1.85 ohm. The unit is ohm. So we have 1.85 ohm, which is approximately almost close to what? 2.0 ohm. And that is what we are actually expecting. It means that these your values here are a bit correct. Are you getting it? What you expected to get is 2.0. So where you get 1.8, 1.9, 2 sometimes maybe we get 2.1 and so on and so forth. So long when you approximate to one significant to one significant value, you are supposed to, to a whole number, to give you 2, then you are actually correct. Now let's see for the next one. It says compare this average value with the value of arrow x. What was the arrow x we calculated? We said arrow s is 2 ohm. Arrow s is how many ohm? 2 ohm. The arrow calculated, which you can say arrow calculated is what? 1.85 ohm. You can now say that the calculated value is almost approximate to the equivalent resistance, which is 2 ohm. Are you getting it? They just want you to compare the values you have. You could say the discrepancy may be due to different experimental conditions and so on and so forth. That is just what you are expected to write. So you write arrow S obtained is 2 ohm and arrow calculated is 1.85, which are approximate values. All right? So that is that. Next, this one is for parallel connection. All right? This one is for parallel connection. It's a very simple something. You are also given arrow 1 and arrow 2. All right? You're also giving arrow 1 and arrow 2 as 1 ohm respectively. So this is 1 ohm. This is also 1 ohm. So we are going to work with each of these values you have here. The first one was V over I. Now, if you notice something, and something that I was trying to grab out from the lecture earlier, these values, V values, are quite lower than our I values. All right? And we are going to see the significance of that as we go on with this lecture. We mean these values here are quite lower than our I values. And we are going to see the significance of these as we progress with this lecture. All right? So, we have the first values there. What is the first value we have here? We have 0.35 divided by 0.50. What did you get as your answer? This will give us the first one, 0.7000. The second one, still V over I, gave 0.5556. Now you are expected to write your values, not the values we have here. Then the other one is 0.5000. Then the other one is 0.4286. And then the last one is 0.3333. Is that understood? So RP is the equivalent resistance of the parallel connection. So we need to calculate RP. Obtain the average value of VI, V over I in the third column of the table RP. So what we are going to do is add all these values together, divide them by 5. The first value here is 0.7000 plus the second is 0.5556, 0.5556 plus the third one is 0.5000. So we have 0.5000 plus the other one is 0.4286. I have 0.4286 plus the fourth 0.8333. We will have 0.8333. Now everything we have here divided by 5. Now when you divide, the top will give us 2.5175, all divided by 5, which will give us 0.5033 ohm. So this is our RP. So RP is 0.5033 ohm, which is approximate what? 0.5 ohm. All right, approximate value. But this is what you should write in your manual. All right, 0.5033. Depend on the result you actually got. It's not necessary that you must write what every other person got as their answer. You write the result you obtained based on your experimental value. All right? So what do you think is the next one? Compare this average value with the value of RP obtained using the formula. R1 was given as 1. R2 was also given as what? 1. So what do you think our RP would be? From calculation, 1 over RP is equals to what? 1 over R1 is 1. 1 over 1 plus what? 1 over 1. Is that okay? Now, at the end of the day, what do you think we are going to have? If you add everything here together, it's going to give us 2 over 1. All right? So 1 over RP would be equals to 1 plus 1 will give us what? 2. Because 1 over 1, 1 over 1 will give us 2 over 1. Is that okay? And what you are looking for is RP and not 1 over RP. So to get RP, just inverse it. Let RP come up, 1 will come down, 1 will come up, this one will come down. So this will be what? RP over 1, since the same thing as RP, is what? 1 over 2. So at the end of the day, RP will be what? 0.5 ohm. Then the question now say compare. If you want to compare now, you see that you got exactly this value. So this person's value is actually correct. So from this result now, you know it is expected that your V values here should be less than your what? I values. Is that okay for parallel connections? Now, I think that is the last part of this. Is there any other question? Yeah, you asked to compare. Yes, compare this average value. Okay. So when you compare now, you are now going to say the value calculated, which is your RP, is 0.5. Right? RP is 0.5. RP initially for the calculated one was 0.5. Then given the resistors R1 and R2 as 1 and 1, the RP also calculated was also what? 0.5, which also states that it is in accordance. The experimental value is in accordance with what you are expecting theoretically. Is that okay? So that's basically everything you need to know for this practical. So how do you write it? It's very easy. Say compare this average value with the value of RP obtained using the formula. You are now going to, after solving, you are now going to say that RP obtained using this formula. You state the formula 1 over RP is equals to 1 over R1 plus 1 over R2 is equals to 0.5. This is in accordance with, or this is approximate in value to the RP obtained from the measured values in the experiment. Hence, there is no much deviation from the theoretical value and the experimented or calculated value. You've commented on that. And if anybody that is marking this will actually know that you've done a very good job there. So that is all for this particular one. We'll see in the next one. Thank you.